Here is our last video for Chapter 3. It is the review, so it is going to go by quickly because it should be a review. So if we are solving by graphing, we've got two lines, 2x plus 6. We start with the y-intercept at 6 and a slope of 2. So we're going up 2, right 1, or down 2, left 1. And again, we're going to do our slope points throughout the entire length of the graph in both directions. So there is line number 1. The second line, we have a y-intercept of -4, and we have a slope of a -3. So we're going down 3, right 1. We want to find the intersection point, so we want to build in the other direction, up 3, left 1, up 3, left 1. When you are solving by graphing, if you are solving by hand, you have to, 1, make sure that you are showing me your slope points, so you're showing me how much you're counting up and over, and then you want to have a point on top of a point. If you don't have a dot on top of a dot, then you do not have an accurate intersection point, and then you have to go to your calculator. Those two are intersecting at the point -2, 2. So I solved that two-variable system of equations by graphing. For your test, you must know how to solve by graphing by hand, substitution, elimination, and determinants. You have to know all of those methods for your test. I will ask you to use each of those methods. Next, we are going to solve a system of inequalities. So we're going to start the same way. We start with a y-intercept of a -3, a slope of 1/2, up 1, right 2, and we're going to continue that the entire length of our graph in the other direction as well. And since it's a greater than, we're going to have a dashed line connecting our points. Our second line, we've got to solve for y before we can graph it. So we've got y is less than or equal to a -3x plus 4. So we've got our y-intercept of 4, a slope of a -3, down 3, right 1, down 1, 2, 3, right 1, down 3, right 1, down 3, right 1. And this time we are going to have a solid line because it's less than or equal to. So we're going to connect our points with a solid line. And now the part of the inequality is we have to shade. For the first one, we want it to be above the blue because it's a greater than sign. So we would have everything there. For our red line, it's less than or equal to, so we want everything over here. The solution to your system is the area which they are both shaded, so the common area between the two of them. And the common area would be everything right there. So that would be the solution to our system, this area between the red and the blue. Alright, so next we want to know, is -4, 5 a solution to the system? You can tell two ways. One, by looking at the graph. If I plot the point -4, 5, -4, 5, I would say yes, because it's contained within the shaded region. Now, if you don't have a graph and you don't want to waste the time to make a graph, you can also check to see if it's part of a solution by looking at the actual equation by hand. We've got two equations. Y is greater than 1/2 x minus 3. We plug in our point of a -4, 5. Our y is 5. Our x is a -4. Half of a -4 is -2. 5 is greater than a -5, so that one's going to work. Then we have a second equation, or inequality. 2y is less than or equal to a -6x plus 8. Our y is 5. Our x is a -4. 10 is less than or equal to 24 plus 8. 10 is less than or equal to 32. So it worked for both of our inequalities. Remember, when you're dealing with a system, the point is only going to be true if it works for both equations, or in this case, both inequalities. So just remember, system, the equations go together. Next, we want to sketch a graph in our 3-variable. And when we sketch our graphs in 3-variable, we've got to use the intercepts. So if I'm looking for the x-intercept, I know y is 0 and z is 0, so I just have 4x is equal to a negative 4, x is a negative 6. You must give me the coordinates of that point. If I want the y-intercept, my x is 0, my z is 0, so I'm left with a negative 3y is equal to a negative 24. So y is 8, so that point is 0, 8, 0. And your z-intercept, we know x is 0, y is 0, so we're left with 6z is equal to a negative 24. Z is a negative 4, so we've got 0, 0, negative 4. This is the work that I must see for all of those points. I want coordinates, I want to see the equations, I want to see the work. So we look at our x-intercept. We have a negative 6, so we start at the origin. We go 1, 2, 3, 4, 5, 6. We have our y-intercept. Here's our y-axis. It's a positive 8, so we go 1, 2, 3, 4, 5, 6, 7, 8. And then our z is the one going up and down. We want a negative 4, so we go from the origin 1, 2, 3, 4 down. We connect our 3 points. And there's the graph of our equation in 3 variables. Now, after graphing a equation in 3 variables, we want to write the equation in function form. If we want to write the equation as a function of x and y, all that means I'm going to do is solve for z. So if I want to get z by itself, I move that 8x over, I move the 2y over. So we're left with a negative 4z is equal to a negative 8x, a negative 2y, a positive 24, then we divide by a negative 4. When you are dividing, you want to make sure that you're being very careful. A negative divided by a negative gives you a positive 2. This is a positive 1/2 y. Don't make the mistake of saying that's 2. Minus 6. So function notation, f in terms of x and y is 2x plus 1/2 y minus 6. That's part 1. Our second part here is to evaluate f of negative 1/12. Well, we know this is the x, this is the y. So we've got 2 times the negative 1 plus 1/2 of 12 minus 6. A negative 2 plus 6 minus 6. 6 minus 6 is 0. So f of negative 1/12 is a negative 2. Okay. Our next problem is a linear programming problem, and this is going to have a couple different parts. We have our objective function, which is c equals 2x plus 3y, and then we have our given constraints. Remember, we're going to start with our constraints. X is greater than or equal to negative 1. That's a vertical line at negative 1, and because it's greater than or equal to, I'm going to have a solid line. Then we have y is less than or equal to 4. That's a horizontal line at 4. And we're going to have a solid line because it's less than or equal to. And last, we have y is greater than or equal to x minus 5. We start at 5, at a negative 5. If we have a slope of a positive 1, we go up 1, right 1. We continue that slope for the entire length going up, and then we've got to work in the other direction, down 1, left 1. Continue that, and that's going to be a solid line as well. Remember, with linear programming, it's really important that you are using that slope formula for the entire length of the graph. Now, I want greater than a negative 1, so I want to the right of our blue line, of our vertical line. I went less than or equal to 4, so I went below the green. So right now I'm limited to just this box. And then I want greater than or equal to our orange line, so I went above. So I went to the right of the blue, below the green, and above the orange, which means our feasible region is this bounded region in between. That gives us our vertices, our coordinates. We use all of the sharp points, and this is why those points are very, very important. You can see that my line got a little bit off, but I know that this is where it's going to be crossing with my slope. So I've got a negative 1, 4 as a point, a negative 1, negative 6, and 9, 4. Because this is a bounded graph, I know that I'm going to have a minimum and a maximum. If it was unbounded, I would only have one or the other. So we take our objective function and we plug in our points. So I've got a negative 1, 4. 2 times a negative 1 plus 3 times 4. Negative 2 plus 12 gives us 10. A negative 1, negative 6. 2 times a negative 1 plus 3 times a negative 6. Negative 2 minus 18 is a negative 20. And our last point, 9, 4. 2 times 9 plus 3 times 4. 18 plus 12 gives us 30. So the minimum is the smallest value that we see, and that smallest number there is a negative 20. The maximum is the largest value, which is at 30. Again, if it was unbounded, you'd only have a min or a max. And our last problem for our review is a word problem. You are going to have 2 word problems on your test tomorrow, so make sure that you are really good with these word problems. All right, Ben is trying to figure out how the points were broken up at the last basketball game. He knows that the sum of the number of free throws, baskets, and 3-point shots total to be 67. So I'm going to let F be the number of free throws, the number plus the number of baskets plus the number of 3-point shots. They had 67 points. The sum of the numbers. Then Ben also knows that if you take the number of points from baskets and add half the number of points from 3-point shots, you get 48 points. So I want the number of baskets and half the number of 3-point shots. That gives us 48. And last, he knows that if you double the number of points from 3-point shots, so I'm doubling the 3-point shots, subtract 10 times the free throws, so 10 minus 10F, and then add 3 times the number of points from baskets, plus 3B. That's going to give us 86 points. So I've translated each of my sentences into 3 different equations, 3 scenarios, 1 equation each. From here, I want to rearrange so that my variables are lined up. So I've got F plus B plus T equals 67. The B plus 1/2 T equals 48. First should come F, so that's a negative 10F. Then is the B's plus 3B plus 2T is equal to 86. On your test tomorrow, it's very, very important that you make sure your variables are always lined up. If there's no variable there, then that's just going to be 0. When we set this up for our inverse matrices, we've got our coefficients 1, 0, negative 10, 1, 1, 3, 1, 1/2, 2. And we know that we're multiplying that by our x, y, z. I know we used f, b, and t, but x, y, z, same thing. Our solution set, 67, 48, 86. And let's go ahead and actually change that to our f, our b, and our t so we don't get confused. And this is going to be our a, our x, and our b. When we are solving, we take the inverse of a and we multiply it by b. So right now, I want you, if you don't have your calculator out, press pause, go to your calculator, enter all of this in, and make sure that you can come up with the correct solution. Once you've entered your matrix in and got your answer, press play and check to see if you were correct. Alright, so you should have hit second, x to the negative first. We wanted to edit. Make sure that you put your 3 by 3 in. Make sure you have all the correct values. Then you do the same thing and do the same thing for b. Then you go to your home screen to get there. Second, x negative first. We want 1. The inverse button is right there. Multiply it by b. So when you want to enter the entries in, you edit. If not, you just hit the numbers. And we find that our solution, our FBT, is 7, 36, and 24. The most important part is knowing what these values actually mean. We have 7 points for F, which is the free throws, which means there's 7 points for free throws, 36 points for your baskets, and 24 points for your 3-point shots.